Okay, today we're going to talk about our naming of polyatomic ions. Last time we talked about transition metals, so we're going to build off of that and get going. So I'm going to go over your notes with you. Okay, here we go. Okay, there. All right, so today we're going to talk about naming those polyatomic ions. To begin with, we're going to talk about why it is that some metals need bromine. Okay? And that is because they have more than one oxidation state. Okay? This is just reducing what we were talking about last time. So if you're at home, you're probably not going to have it on yellow paper, but we have given you a copy of this. Okay? So some metals, the ones in the middle, the B group, need a Roman numeral because they don't have those set oxidation numbers. So at the beginning of the year when we learned on our group 1 and 2, and then our nonmetals. These all have their set oxidation numbers. And at the beginning of the year, we just told you, don't worry about these, we'll get to them later. Well, we learned last time that these are troublemakers, the B group. They need Roman numerals because they can bond in unpredictable ways. They can have more than one different state, an oxidation state. They can have several. So the Roman numeral will tell us what that atom has done in that particular bond. Nonmetals do not need this at all because all of our nonmetals, everything over here, all the nonmetals have a set oxidation number. They're never ever going to change. So when they bond, they don't differ at all. Okay. Why doesn't calcium need a Roman numeral? We talked about why don't all the metals. Calcium is located in group 2. So calcium is not going to need a Roman numeral because it's always going to have in a bond a loss of 2 electrons. It's the middle ones, the B group, that can vary. All right. So your periodic table at home, if you're at home, may not be yellow, but I want you to get this one out. And from there, we're going to look at this list. I'm on the wall right there. This area right here where it says common polyatomic ions. And I know for you, it's coming up backwards in this picture, but it's common polyatomic ions, that's what we're going to be looking at. We give you these, which is super nice. You don't have to memorize them, which is amazing. We give them to you. It's just your job to locate them and be able to use them on your test. So there they are, right there. So like we said, thank your lucky stars that we don't have to memorize them because that would be really, really tough. So poly means many, much or many, and atomic is from the word atom. That's what that means. So, and you can see in this list, there are many atoms in there. There's more than one. Not a single element. They're groups. Okay? There are several different elements. So most common chemical formulas will contain polyatomic ions, which are groups of atoms bonded together that carry a charge. One interesting thing about the polyatomic ions is that they stay together as a group when they undergo reactions. So when you see this in here, they stick together. I always tell my classes, buddies stick together. Wherever you see these charges, they are not going to change. What am I talking about? I'm talking about those little numbers right there. See those little numbers? That means the entire group will have that charge. And we don't take them apart. We don't try and pick them apart. Because they stay together, we also name them together. The names of these ions are given to you, right? There they are. You don't have to memorize these. You just have to know where to find them. Okay? So if you see, and again, I know it's backwards, I'm sorry. But if you see SO, right, SO3, you're going to know that fully. You'll need to notice this on your test and then be able to look it up on your table. If you notice, most polyatomic ions are negative. One exception that we need to know is ammonium, and that has a charge of +1. Okay, so most of them have extra electrons, which is why they have that negative charge. Negative charge means they have more electrons because the electrons have negative charges. That's why we see that up there. Ammonium is the only one that we will use that is positive, and it gives away an electron. So ternary is a fancy word for our polyatomic, and they are going to have at least 3 elements. We're looking at our polyatomic ions. So the first thing I'm going to do is name the metal. We always name the metal first. The next step is to write that name exactly as it is written on your periodic table. Do not change the name of the polyatomic ion. Okay? Don't change it. So in my first example, I've got sodium. Okay, I need to name the metal first, sodium. Always start with the metal. Na is sodium, and then I'm going to say nitrate. Sodium nitrate. Where did this NO3 come from? This came from my polyatomic. Okay? So when I see that, and parentheses are going to help you find that. When you see that, you're going to find it on here, whatever that symbol is, and then just write it down as you see it. You just have to match it up. All right, let's look at this one. Okay, so first I'm going to name the metal. Okay, that is barium. Barium. Sorry about my handwriting. And then I'm going to just match it up. I'm going to look for that OH in my list. I'm going to look on my list. You don't have to memorize these. I'm going to look on my list. I'm going to find the OH. That is hydroxide. And you're just going to copy the name exactly like you see it. So that's going to be barium hydroxide. It's hard to write. Okay. This next one is interesting because it's not starting with the metal, right? And that's because right side there I have my one exception. So this is the exception. This is the ammonium. Okay? Ammonium chloride. Ammonium chloride. And cut off. So you can see it up here too. And then the next one is going to be nickel. And then I'm just going to find, again, ClO3 on my polyatomic list. Nickel chlorate. Okay? So use the parentheses. Anytime you see parentheses, you should be thinking, oh, this is a polyatomic ion that I'm dealing with. Okay? So be on the lookout for those parentheses. All right. So there they are with better handwriting. So let's practice some more. So K, I see this K. So that's a metal. You name the metal first. That is potassium nitrate. Once again, use your list. Just copy it exactly like you see it. These are not hard to name. They're actually much easier than I think the other ones because it gives you the list and you don't have to memorize them. Okay. Here's a little bit of mixed naming, right? So what do we know about iron? It is a transition metal. This is where things get a little more challenging. Iron is a transition metal. Where are we going to get the charge? We got to get it from the polyatomic list. So I need to find the 29, okay, that CN and use that charge to give me my Roman numeral. So I can look and I can find the CN. Here it is. It's got a -1 charge. Okay, so I need to reverse it to crisscross, see, to get iron with 2 cyanide. So because that has a -1 charge. All right. And be careful because some of them sound similar, like silver phosphate and phosphite. They sound similar, but you have to be looking very carefully for the differences. So look at this very carefully, right? And that will give you the name. All right, so that's for our naming. Naming, I think, is simpler than writing formulas. To write our formulas, the first thing you're going to do, step 1, is always going to be to write the symbols. Cation first, then the anion. Cations, remember, are metals. One thing I tell my students, like a cat, right? Cation. And this is very silly, but I was told not. I say metals throw me off. That helps you remember metals. Okay, write the symbols first, cation first, metal first. So calcium is a metal. Okay, and then I'm going to write the anion. Chlorate, chlorate. So if you see an ACE ending, that's another good hint. It's not an IGE ending like most of our naming. If it ends in an ACE or an ICE, you also want to be thinking, oh, okay, I'm dealing with a polyatomic ion. Okay? So symbols first. So my symbol. My symbol. Here we've got CA, calcium. Now I'm going to write chlorate. Sometimes it's helpful to write in your parentheses. Chlorate. But you don't have to. C-L-O, and that is ClO3. Okay, step 2. Next, we're going to, above each symbol, write the oxidation numbers. Okay, so let's think about what is the oxidation number for calcium. Can we get that? This is just from the valence electron. So calcium is +2. Chlorate, we get from that polyatomic list, it's a little number. So chlorate, you just want to be looking for the superscript that's outside of the parentheses. Chlorate is a -1. That 3 is to crisscross. Okay, so the 1 is going to come over to the bottom. The 1 is going to crisscross and move over here. Okay, the 2 is going to come over here. So sometimes it's helpful to have the parentheses. So the 2, oh, still trying to write. Well, okay, so It's not gonna work for me. The two, basically, I'll draw it on a, we'll do it like that. Okay, so CA plus 2 I'm gonna do it on my post-it note. So they crisscross, right? And then at the end, we have to reduce and erase. So that 2 came over here. And then you're gonna end up with, I'll just over here. I need to do this. I need to, okay, there we go. I'm gonna end up with C A C L O 3 minus 1 plus 2 crisscross. The 2 is gonna come over here, and 1 is gonna come over there. These do not need to be reduced. We can't reduce this any further. So the final answer is CaClO3 2. All right. Now let's practice some more. Okay. Iron 2. So we have one symbol. Fe chlorate. I'm going to find it on my list. Chlorate. That is ClO3 minus 1 charge. And then here's your charges. I got a minus 1. And I have to think about, okay, so this is iron 2. The name is telling me it's iron 2, so I know I have a plus 2 charge. And they're going to crisscross. Crisscross, so 1's going to come over here. I can't reduce this. So I'm all done. Okay, you don't have to write the 1. You can. I'm not going to count it wrong, but you don't have to. It's understood. So our next one is going to be sodium chloride. Sodium is Na. That's an N. Chlorite. So I'm going to find it on my list. Chlorite. It is ClO2. Okay, sodium, I know has a plus 1 charge because it's in the group 1. Has a plus 1. That's a 1. Chlorite, you just look on your list, has a minus 1. So if we crisscross those, it's just 1 and 1. It's going to be okay, this one's interesting because it's 2 different polyatomic ions. Ammonium, which is on my list. It's okay if there's 2. That's fine. Okay, just copy it down. NH4. NH4 perchlorate. Ammonium has a plus 1 charge. Perchlorate is on your list, and it is ClO4 with a minus 1 charge. ClO4 with a minus 1. If you crisscross, it's 1 and 1. There it is. Okay. Oh, there's meter. You ready? Okay. Copper 2 sulfate. Again, we're going to be writing those symbols. Okay, Cu with a plus 1 charge. Okay, and go through this quickly. Cu I know it's plus one because it's the Roman numeral, but it's telling me. That's where I got that one from. And then sulfate. SO4. And that also has a plus or a minus 2. Sorry, minus 2. They're going to crisscross. And remember, when you crisscross, you drop the plus and minus. And there's your final answer. Gold 1 acetate. Gold is AU. Plus 1 charge. I know because of that 1. Acetate. That's a longer formula, but again, you don't have to memorize these, so that's okay. 3, 2. And then we look under this, got a minus 1 charge. They crisscross. So the 1 comes down here. The other one comes down here. And I don't need to reduce. Okay, next one, chromium 3. Chromium. Got a plus 3 charge. I know because of that Roman numeral. Plus 3. Dichromate is Cr2O4 with a minus 1 charge. Then we're going to crisscross. So 3 is going to come over here. Crisscross. A 1 is going to go down here. Okay. And there they are written. And that is it for our naming. So I actually think this is much easier, especially because we give you this list. The key is to have that list. All right. So now we're going to go practice